Hey Amanda, this is Ixl K7, and then I'll go ahead and move on to K8 and K10. So for all of these, you have to complete the proof. Now, like I mentioned in the previous Ixl video, it's useful if you draw out the diagram that's given so you can mark it, so you can see exactly why in these cases the triangles are congruent. So here we are going to complete this proof. I have already copied that image here. We are told that GH is parallel to IG. That's the arrows that are already marked. Angle H is congruent to angle J, which is also already marked. Angle HGI and angles GIJ, so HGI and GIJ are also congruent. And that's because they're alternate interior angles, since you have parallel lines, and this would be considered the transversal. Then GI is congruent to itself, and this is because of the reflexive property of congruence. Now what we have here is we have an angle, and a side. Remember that when you're looking at the triangles, you have to go in order, whichever way you find easiest. Usually counterclockwise is the way to read your triangle. So we have angle, side. That means that these two triangles are congruent by AAS. Okay, let's complete this proof now. Let me just go ahead and copy that diagram, which is somewhere around here. Where is it? Here we go. Okay, so here's that diagram. We are told that Y is congruent to angle V. That's already given. UX is congruent to UW, also given. Angle XUY is congruent to angle VUW, which is also given here. Then the measure of angle WUY is equal, so WUY is equal to WUX plus XUY, which is true because of the additive property of angles. Then VUX, so VUX is congruent to is equal to VUW plus WUX, also because of the additive property of angles. And then we have here, what they did was that they essentially substituted, because let's see here what they substituted. WUY is, you see here that they substituted XUY with VUW since they are going to be the same angle, and that's by substitution. So those two angles would be congruent as well. So this is VUX, which is this angle here, is congruent to WUY, which is this angle here. Now we are trying to show that triangles UVX, so this large triangle here, is congruent to UYW here. Now that's hard to see because we got a lot going on, so I'm going to draw them separately. So this is UVX, and then this is UWY. All right, so we have V and Y that are congruent. We have angle U is congruent to angle U in both triangles, and then we have that UW is congruent to UX. So this is another case of angle, side. So you see how I'm going in the counterclockwise direction, and I get angle, side. Okay, let's try this one more time. Okay, so I have already copied that diagram here. Now, let's see what we have. We have that angle UZV, so UZV, so this angle is congruent to WYX, so this angle. We know that YZ is congruent to VW. So VZ is equal to YZ plus VY, so this whole segment here. And then that WY is equal to WV plus VY. And then again, they substituted here that WY is equal to VZ since they have the same additive properties there. So you see how it's VW plus VY for both. So they made both of these equal to each other by substitution. So what we have here is, let's see. We only seem to have one main side and one angle. So sorry about that. So this is essentially congruent to this here. That's what it's trying to tell you. And then I missed this angle here, that XWY. So this angle is congruent to UVZ. So this angle. So what we have here is angle, side, angle. So that's how they are congruent. All right, let's see if we can work this out. So we have here that all these given statements, which is marked already, and then we have that IK. So IK is equal to JK plus IJ. And what that is that we're adding this segment to this segment. So as long as you know you're adding segments, that means that you're adding lengths. So that is the additive property of length. Now here, anytime that you have a side where it's being added, see how these are all side lengths? That's the additive property of length. So you don't really have to think much about it. Now here in this next one, we have that QU is equal to QR plus QT. Now what we have here is that we have that QU is equal to TU plus QT, and that RT is equal to QR plus QT. But we are told earlier that TU and QR are congruent. So what they've done is that in the statement for QU, everything is the same except for TU was substituted for QR. So that would be substitution. Now it tells you that RT is equal to QR. So we have that RT is equal to this and QU is equal to that. That means that RT is equal to QU. That is the transitive property. A is equal to B and B is equal to C. Therefore, A is equal to C. That's what that means. So this is the transitive property of equality because these are using equal signs and not congruent symbols. Okay. Over here, same thing. We have these lengths here that are being added. So this must be the additive property of length. A lot of these make sense the more you do them. Now, everything here is pretty much drawn out. If we're trying to figure out that these triangles are congruent, read your triangle counterclockwise. We start with an angle, and then an angle, and then a side. So this must be angle, angle, side. Okay, we'll do this last one and then move on to the next IXL. All right, so for this one, we don't really have a lot drawn out, so I'm going to go ahead and take a picture of this. All right. So as you can see in the description first, we are told that angle GIH is congruent to EJF. So that is a given statement. Typically, the first couple are usually given. Then angle FEJ is congruent to angle GHI, which is also a given statement. So I'll put that in a moment. And then we are lastly told as a given that FG is congruent to IJ. So those are all given statements. Now, we have here Fj is equal to Ij plus Fi. Without even having to look at it, I know that this is the additive property of length since we are adding length measures here. Same thing for the second one. If you look at it, Gi is going to equal to Fg plus Fi. We would have to add these two lengths together. So this is also the additive property of length. Now where it changes here, even though we are adding lengths here, this is actually by looking at our previous statement 4, this is where we were adding lengths, but then this is for Fj, and then we have another statement about lengths for Fj. So it's not going to be the same reason. We have Fj is equal to Fg plus Fi, and the reason for that is we are told that Fg is congruent to Ij. In our original Fj statement, it says that Ij plus Fi, and now it's Fg plus Fi, and that's because they substituted the Ij with Fg. So this is substitution. Now, because these two now are equal, see how Gi and Fj are the same. If you have two statements that are telling you about two different things equaling to the same thing, then that means that this is the transitive property of equality. An equality because we're using the equal sign and not the congruent symbol. Now, how do we know that these two are congruent? If I look here at my diagram, I have it marked. We have angle, angle, side. So angle, angle, side. Okay, we're going to stop here and move on to the next one. This is K8. So here, this is proofs involving corresponding parts of congruent triangles. If you know that triangles are congruent, then that means that all of their corresponding parts will also be congruent. That's what that means. So first here, I don't really need to look at the rest of the proof to know how to answer this one. For angle SRT is congruent to RTU, that's because these two lines I am told are parallel. And this line here is a transversal. So those two angles, SRT, which is this part here, and RTU, which is this part here, these are alternate interior angles. Okay, now over here we have the measure of the one that we're trying to figure out is that the measure of angle PSR, so PSR is going to equal to the measure of angle PSQ plus QSR. What I'm doing here is I'm adding parts of these angles together to give you the big angle. So this is the additive property of angle measure because I am adding angles. Again, the statements make sense with the reason. What are you doing? We're adding angle measures. So this must be the additive property of angle measure. All right, now here we have that angle U is congruent to angle S. I'm just going to go ahead and copy this diagram because we may need to draw it up. Okay, so angle U is congruent to angle S, that's given. QS, so QS. So it looks like we have these two separate triangles. So I'm going to draw them separately. We have this one here, and then this one here. This is S, this is V and Q. And then this one here, this is R, this is Q, and this is U. So angle S is congruent to angle U. QS is congruent to QU, which is also given. Angle Q is congruent to itself. I think I drew this wrong. QRU. Oh, I marked the wrong side. I marked RU. It's QU. Okay. So when we look at these triangles, well, first of all, this statement, angle Q is congruent to angle Q. This is the reflexive property of congruence. Remember that when you're looking at a reflection, it's basically yourself. So that's whenever you have, angle Q is congruent to itself, that's always the reflexive property. The difference between knowing whether it's the reflexive property of equality or congruence depends on the symbol. Now we have here, how are these two triangles congruent? If I look at my diagram, I have an angle and then a side and then an angle. So this is ASA. And then here the corresponding parts these are corresponding parts. QV is equal to QR. Whenever you're told if something, a part of a triangle is congruent, after you are given that the triangles are congruent, that is CPCTC, which stands for congruent parts of congruent triangles are congruent. Okay? Now here we have that RV is congruent to TV. Now it says here that the triangles STV, so let me just get a picture of this here. Now I'm going to draw those two triangles separately just so we can see them. We have STV, so STV and URV. This is URV. So we have that these two triangles are congruent. Then we have that RV is congruent to TV. Now these are corresponding parts because they are part of the same congruent triangle. So when you are told that two triangles are congruent, then their parts are also congruent. And then SV is congruent to UV. And that is probably going to be the same thing. SV is congruent to UV. Also congruent parts of congruent triangles are congruent. Because again, we are basing off of the parts of the two congruent triangles. So CPCTC. Okay. Now here we have that angle WYX. WYX is congruent to VWY. So WYX. Okay, so we have this angle here and then this angle here. Those are congruent because those are alternate interior angles. Whenever you have parallel lines, this is the transversal, or this is also a transversal, but those angles are created by this transversal. And they are on the inside of the parallel lines and on the opposite sides of the transversals, so alternate interior angles. Then because you have that, let's see here, how did they come up with the transitive property? WVX is congruent to VXY. WYX is congruent to VWY. So VWY is congruent to VXY. So these two here would be then congruent since they're both equal to the same angle. So now angle WYX is congruent to VXY. So this one is congruent to this one also because of the transitive property, because you are told that WYX is congruent to one angle. So A is equal to B, B is equal to C, therefore A is equal to C. So that's the transitive property of congruence as well. Then we have the reflexive property of congruence because they are the same sides. Now, in order to figure out how these two triangles are congruent, let's draw them out separately. So I'm just going to draw it here on this side and just focus on those two triangles. We're trying to show that VXY, which is this one, VXY, is congruent to WYX. So then this one, WYX. So let's draw everything out. We have that angle WVX, which is not there. Okay, so let's go here. WYX is congruent to VWY. That's not there. So let's move on to the next one. Angle VWY we don't have. Okay, angle WYX is congruent to VXY. We also have from the given statements that WY is congruent to VX. Okay, and that XY is congruent to XY. So what we have here is side, angle, side. So that's how those two triangles are congruent. All right, let's wrap this up with one more, and then we'll move on to the next IXL. So I'm just going to copy this diagram just in case. Okay, so what do we have here? We have that angle SRT is congruent to angle URV. So what I'm going to do here is I'm looking at my final, well, we don't need to, that's fine. Okay, then angle S is congruent to angle V, and RU is congruent to RT. Now, actually, we don't even need the diagram for this one. So here these are, we're adding angles, right? Angle TRV is equal to angle TRU plus URV. So that's the additive property of angle measure. Then the measure of SRU is equal to the measure of SRT plus TRU, also the additive angle property of angle measure. Now we're going back to the measure of angle TRV, which we saw here is TRU plus URV. But we are told that URV is equal to SRT. So that's what they substituted here, URV with SRT. So this is substitution. Okay, we'll do this last one since this is all having to fill in. So let me go ahead and copy this diagram. Pretty sure we'll need it this time. Here we go. Okay. So we are told that W is the midpoint of SU. That is given because that is at the very beginning. SV is parallel to TU. It's given also in the diagram, even though it's not stated here. So this is also given. Now angle S is congruent to angle U. Now when you look at your diagram, S is congruent to angle U, and this is because they are alternate interior angles. These are the parallel sides. This is the transversal. Therefore, this is alternate interior angles. Now, angle T is congruent to angle V, and that is for the exact same reason. There are also alternate interior angles, but using the other transversal. So T is congruent to V. SW is congruent to UW. So, oops, SW is congruent to UW, and this is because we were told that W is the midpoint. So a midpoint by definition cuts your segment in half. So this is the definition of a midpoint. Now looking at the diagram, if we read this, what we have here is an angle, angle, and then a side. So that's how they're congruent, by angle, angle, side. And since I have shown that my triangles are congruent, then their corresponding parts are also congruent. So this will be CPCTC. Okay, let's go ahead and move on to the last IXL. This is proofs involving isosceles triangles. So let's go ahead and copy these diagrams. We have here that GJ bisects angle HGI. So if it bisects, that means that this angle is congruent to this angle. We have that GI is congruent to GH, and that's given. So I'm going to mark that up there. Then we have that these two angles are congruent because of the definition of angle bisector. I already marked that. And GJ is congruent to itself because of the reflexive property. Therefore, these two triangles, you see you have a side, angle, and then a side. So this is congruent by SAS. And once I've proven my triangles are congruent, then the corresponding parts are also congruent. So CPCTC. Now over here, we have K is the midpoint of IJ. So once more, let me go ahead and copy this diagram. Okay. If K is the midpoint, then that means that JK is going to be congruent to IK, which is given here in statement 3. HI is congruent to HJ, and that's a given statement. HK is congruent to HK because of the reflexive property. So what we have here are 3 congruent sides for each. So this is SSS, side, side, side. And again, I've proven my triangles are congruent, therefore their corresponding parts are congruent. Okay, let's get this next one. Ooh, that's a shortcut. Perfect. All right, so we have here that VY is perpendicular to WX, and that's given, and you see that's why we have the 90-degree symbol there. We have the two angles are congruent, and then we have that angle VYW is congruent to VYX. And that's true because if it's a perpendicular bisector, then both angles would be 90 degrees. So that would be that all right angles are congruent. Okay, let's get this next diagram here. All right. We have that S is the midpoint of QR. So because that's the midpoint, that means that this side is congruent to this side. And that PS is perpendicular to QR. So that means that this is 90 degrees and that is 90 degrees. Angle PSQ and angle PSR are congruent, and that's because they're both 90 degrees. So that is all right angles are congruent. Okay, let's get this diagram as well. We have here that angle HFI is congruent to GFI. So HFI is congruent to GFI. Okay. Angle G is congruent to angle H. And that FI is congruent to itself because, again, the reflexive property of congruence. Now, by looking at my diagram, what we have here is an angle, and then a side. So AAS. So by drawing these out, you get a much clearer picture as to how these triangles would be congruent. Now this one is easy because if you look at it, you don't necessarily need to know the rest of it. You have here that UX is congruent to UX. Again, that is the reflexive property of congruence because it's using the congruent symbol. Then they've already proven that these two triangles are congruent. So if they're congruent, that means that their parts must also be congruent. So that's the CPCTC. Okay, we'll do this last one. Oops. So we have here that angle VTW is congruent to UTW. Then we have that TW is perpendicular to UV. So that means that this angle is 90 and this angle is 90. And you can see that these two statements here are what's written on top. So both of these are given statements. Now we have here that angle TWU is congruent to TWV. TWU is congruent to TWV. That's where you have your 90 degrees. So that is that all right angles are congruent. Now your next statement is that TW is congruent to TW. Again, that is the reflexive property of congruence. And finally, these two triangles are congruent because you see here that we have an angle, a side, and then an angle. So ASA. And if those two triangles are congruent, then that means their corresponding parts are also congruent. So CPCTC. And those are your IXLs. I hope that helps.